So as we begin our foray into trigonometry, I feel like I really wanted to start with this lesson just called Why 360 Degrees, or for that matter, Why Degrees. And what I really want to talk about in this lesson is, like, where did 360 degrees come from? Like, where did this concept of degrees even come from? I feel like if you were to ask, a student from geometry, or, a student, what do you remember from geometry? One of the things they'll probably tell you is this idea that, well, I remember that a circle, has 360 degrees. And it's sort of like, why? There's a lot of answers for this, but one of the more basic answers is the Babylonians used a sort of a base 60 counting system, which basically means 60 was an important number for them. And so there's this idea that, 360 is, related to 60, and 360 is divisible by a lot of things. It turns out 360 is divisible by, like, 1, 2, 3, 4, 5, 6, 8, 9, 10, 12. It's divisible by a whole lot of things. Basically means we can take that number and split it up into lots of pieces. So there's a lot of reasons why 360 makes sense. Like, I can see, like, why they chose it, I suppose. But somebody could make the argument, well, why didn't they use 400? Why didn't they use 600? Why didn't they use 1200? Why didn't they use some other number of degrees? And there really aren't any good reasons for it. The reality is 360 degrees is the number they used because it's the number that they used. So it's interesting, when I ask you what's a 45-degree angle, everybody kind of comes back with this idea and says, this is 45 degrees. And I need to shatter this. There's a better way to talk about angles. But before we get to that, I guess I need to share with you why degrees is weird and why it doesn't work really well. Saying that this angle over here is 45 degrees comes from the idea that if you were to take this circle and split it into 361 degree, I'm not going to do this, 361 degree chunks, and then put 45 of them together, we'd end up with this 45 degree angle. It just doesn't seem to make sense. On top of that, 360 degrees bothers me, because 360, like, it's not a number that's connected to anything. Sometime, a long time ago, somebody decided 360 degrees was the number of degrees we were going to use. And it made sense, it's good, but there's a better system, and that's what I'm going to talk to you about next. That better system is something called radians. And the reason I love radians, the reason radians are great, is that it's based on a real number, right? So bear with me, here we go. Imagine a circle, and I'm going to do my best to draw a good circle. I'm really pretty proud of that one. That was pretty nice. So imagine you've got a circle, right? What I'm going to do for all of my angular thought is I'm going to sort of imagine that all of my angles are going to start here. Like sort of in the, you can think of this as like the positive x direction. So that's where all angles are going to start. So a 45-degree angle would look something like this. A 90-degree angle would be this. A 135-degree angle would look like this. A 20-degree angle would look like this. So now imagine that this circle had a radius of 1, right? So we're going to call this thing a unit circle. And you're going to hear a lot about this unit circle over the next several days. So this unit circle has a radius of 1. With that in mind, what's the circumference of this circle? Well, hopefully you guys remember that the circumference of a circle is 2 pi times the radius. So the circumference of this circle is 2 pi. In other words, the distance all the way around this circle is 2 pi, right? So here's what I'm going to say. When somebody says, hey, I'm thinking of an angle that is a 45-degree angle, rather than thinking of it as a circle having 360 degrees, which you've all heard me say is arbitrary, right? Like there's no reason to have 360 degrees. Instead of thinking about that, there is a reason that the circumference is 2 pi. The reason is, it is, right? If the radius is 1, the circumference of the thing will be 2 pi. So what we can do is, instead of measuring this part of the angle that honestly can't be measured, instead I can effectively say, how long is this? What part of the circumference did I cut out, right? And I'll tell you now, that part of the circumference is pi over 4. So the idea is, instead of measuring some arbitrary internal angle thing, I'm saying, imagine that angle was sitting on a unit circle. How big of a chunk would it cut out? My goal in this video isn't really to get into the calculation of these things. Some of you may be wondering where that pi over 4 came from. One place where you can see it is sort of setting up a ratio. You can look and say, well, what is the ratio of 45 degrees to 360 degrees? Right? That ratio should be the same as whatever radian measurement I'm trying to find compared to the entire circle, which is 2 pi. One of the themes we're going to sort of get in these lessons is that 360 degrees sort of means the same thing as 2 pi radians. So if you were to cross multiply and solve this thing, you would end up finding out that it is pi over 4. Okay? So in this lesson, really all I'm pushing is this idea that radians are going to be a superior way to think about angles when we're doing calculus, because pi over 4 is a real number. It's not based on, a few, 1,000 years ago, somebody decided that 45 degrees, 365 degrees was, I'm sorry, not 365, 360 degrees was the way to go for the circle. Instead, we're basing it on a real number. We're basing it on the idea that an entire circle is 2 pi, and we want to know how much of that is being cut out here. Again, this first video isn't supposed to be about computation, but I sort of want to give you one more example to think about. What if somebody gave you the angle 60 degrees? So here's this 60-degree angle. How do we think about what the radians are for this angle? Like, what is the radian version of 60 degrees? And we could just use a formula to convert it, but I want us to understand where radians comes from. Where it comes from is the idea that we take this measurement and we sit it on a unit circle. That circle was less good than my first one was, but it's still not bad. So the idea is, okay, if we take this angle and just look at one unit of it, and we look at our 1 unit circle, what amount of the circumference will be cut out by that 60-degree angle? So the radian measurement is basically how long is this arc of the unit circle that gets cut out. And we mentioned before, one way that you can do that is to set up a ratio. To say 60 over 360 should be equal to my radian measurement divided by 2 pi. Okay? So cross multiplying, you'll get, 120 pi equals 360x, which means x ends up being 1/3 pi, or pi over 3. Fair enough. So the concept of pi over 3 radians will be equivalent to our thought of 60 degrees. This is probably a foreign concept now, but as we go through this and as we work through the next few days, I really want to work to us being more comfortable with the idea of a radian measurement of an angle as opposed to a degree measurement for an angle.